Hi everyone, hope you are doing well. Today we are going to study about binary search. Uh, firstly, I will give you a real life example. Uh, then after that I will solve a coding problem for you. Then we will analyze time complexity of binary search. After that I will write pseudocode, and at last we will write C++ code. Okay. Now let's move to real life example. I think that everybody has used binary search in their real life. Let's take an example of dictionary. In a dictionary, the words are present in a sorted order. Okay. By sorted order, we mean that A, B. Firstly, A words started with A are present, then B, then C, then D, then E, F, and so on to Z. Okay. Now uh, now let's take an example, like we are finding a word started with D. That is, we are finding a word dog. Okay. the what we like we If we are finding a word in a dictionary, what will we do? We Let's assume that this is a dictionary. What will we do? Uh, we will choose some random we will open some random page, and we'll check what word present in that page. Okay. Like we are searching for dog, and we open a random page, and the where words started with F are present. Like ठीक है. Okay. Like words starting with F are present. Now we know that the word present before F, like in the left side of dictionary, are present are like present are A, B, C, D, and F, because the words are in sorted order. So it means that the words present with D is on the left hand side. Okay. But in the so we can so there is no need to check in right hand side, because the word started with F or words greater than F are present in the right hand side. Okay. So we reduce our search space by half. Like firstly we have to search in a whole book. Now we have to search in this half book. Okay. Now our search space become A to, like our search can become A to F. Now again we will choose some random page, like we choose mid. Like this portion have 500 pages. Now we choose mid, like which is 250th page. Okay. Now if we are choosing, like we choose 250th page. Okay. In 250th page, the words which are present in that page started with C. Okay. Now let's take 8C. Now it means that the word which present on the left hand side of this book is is present or A, B, or C, because D is in A, B, C, D is in sorted order. D present after C. So by this we conclude that the D will be present on the right hand side. So there is no need to check on the left hand side. Okay. So we will exclude this portion of book. So we have to search only in this portion of the book. Okay. Which is very small, you can see. Like now again we will do. Now our search page becomes C to F. Now we have to search in between C and F. Now let's we take a random page where the word dog is present. So we find our dog word. Okay. Now you can see that instead of doing first page, second page, third page, fourth page, we randomly choose some page and then compare that. If our word started is less than that word, it means that it is on left hand side, otherwise it is on right hand side. Similarly, same approach will be which we will be used in binary search. Now let's understand what is binary search. Now I will take example, coding problem example. We are given an array, like we are given an array of 8 integers: 1, 2, 3, 4, 5, 6, 7, and 8. And we have to search a target value 8, like target equal to 8, and we have to search whether the target 8 is present or not present. So what we will do, the first approach that came in our mind is that linear search. What is linear search? By linear search we mean that we check for all indexes. Like firstly, uh, By linear search we mean that we have array of 10 elements. Firstly we are check for first element, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So in that case we are linearly checking. That linear mean we are iterating linearly, 1 2 3 4. So in that case we have to check for n elements, so the time complexity is big O of n. Okay, because for like that, if we are searching for 8, we firstly compare with 1, then with 2, then with 3, then with 4, then with 5, then 6, 7 and 8, and finally we get our answer like 8 is present. Like if we are searching for 9 which is not present, but in that case also we have to do an operation. Okay, so in worst case time complexity is big O of n. If you don't know what is time complexity, then by then we you think that by comparing like that is we are comparing 1 and 8, that they are equal or not. You assume that that comparing take 1 second. Okay, so if the array of size is 8, so we have to check for 8, that time will take equal to 8 seconds, because n is 8 size of array, so it will take around n second. Like in this case, which is very like 8 second is very less, so we can say that okay, okay, I will find. But assume that there are 1 crore entries, like 1 crore entries in real life example. We have to search for some entries, like there are 1 crore entries, and we have to search for uh, 1 lakh entry. So we have to linearly search 1 2 3 compare. So by comparing, it take, like we are crore, so it take crore second, 1 crore second, so which is very large. So instead of searching linearly, we do binary search. But the condition for binary search is that array must be in sorted order. By binary search mean that array is in sorted order. What do you mean by sorted order? Like by sorted order, we mean that the array is in ascending order or descending order. By ascending order we mean that like increasing order, 1 2 10 14 15 100 2000, like it increasing order. Okay, like 1 2 3 8 10 100. By decreasing order we mean that firstly the greater element is present like 100, then all the element present on this right hand side are smaller like 99. Now again on the right hand side the element will be smaller than 99, like 96, 94, 92, 1, like in this pattern. Okay, so both cases the binary search will work. Okay, so binary search will like let's take the example how binary search will work. I will explain. 10 let's take example of array 10 20 30 40 50 60 70 and 80. Okay, 10 is present as 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index. Now let in this case our target is 9, target is 80, target is 80, and we have to search for 80. So we what will we do? Firstly we will take two variable like low and high. Low and high will define what will be our search space, like in which portion of the array we are going to search for that element. Okay, initially in starting of our low is 0 and high equal to n minus 1, where n is the size of array, n minus 1 because the indexing start from 0. Okay, so then we will find mid. And how we find mid is low plus high by 2, mean that middle of both this middle of the array. Okay, like array is of 8 size and the middle, what is middle is 4, but in this case low is 0 and high is 7, so middle is 0 plus 7 by 2, which is 3.5, but we take it integer, we take it as 3. Okay, now we compare with mid element. In this case the mid element is 3, index is 3, so we compare with 3, like we compare, this is mid element. Okay, now we compare our target with mid. Then now we when we compare our target with mid, target comparison with mid. Now let's take now we give name v to this our array. Okay, now we compare v of mid. Okay, the value present at mid index equal to target. First case is this: if the value at mid is equal to target, it mean that we have find our result. We simply return our answer, return mid, because we have to return the index at which our target is present. And the second case become, in that case v of mid, that is value present at mid, is greater than target. It means that, like, we are in this array, assume that we are searching for 20, but mid value is 40. It means that the value which we are searching is present on the left hand side of the array. So there is no need to check in this right array. Okay, we discard that array, because the in sorted array there is it is because in sorted array the element which we are standing in at current time, the element right to it are greater and left to it are smaller. So there is no, if the element which we are comparing, that is mid element, if it is greater than target, the element right to it will also greater than that target value. Okay, so we return. In that case we don't return, because in that case our search space become like, in case of we if we assume that our target 20, then our search space become low to mid minus 1, like this: mid minus 1, mid minus 1. Okay, so what we will assign, we will assign high, like we will assign high to this mid minus 1, because our search space reduces. Hope you get this point. Like, if we know that the element present on the right are greater, so it means that if our target is present on the left hand side, so we reduce our search space by half. Like, firstly our size array is 8, then we reduce it to half, like 4. Now again we will like, in that case our high become mid minus 1. And what will be third case? Now third case left is if v of mid is less than target. Okay, now in what will happen in this case, like we are searching for 80 and our value at mid is 40. Now v of mid is less than target, it means that target is on right hand side, so there is no need of searching in left hand side. So in that case our low become mid plus 1, because mid value is less than target. It may possible that mid plus 1 is equal to target, so we do low equal to mid plus 1. I hope you understand this point. Now, but this is simple binary search. Okay. Now let's dry run this. Okay. To understand it better. Now let's take the same example, like 10, 20, 30, 40, 50, 60, 70 and 80, like this is 0 index. This is not working properly. Like, like, why it is not working? Like, this is 0 index, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6 and this is 7. Now initially our low is 0 and high is 7, so we will find, firstly, in first case low is equal to 0 and high is equal to 7. Okay, high is equal to 7. Then what will be mid? Mid equal to low plus high divided by 2, which is 3. Okay, so now we compare v of mid with our target. Compare with mid target. In this case, v of mid, what is v of mid? V of mid is 40. 40 is less than target. What is in this case, what will we do? Like, for v of mid is less than target, in this case we do low equal to mid plus 1. Now our low become mid plus 1. What is mid? Mid is 3. Now low will become 4 and high will remain same as high as previous 7. Now again we find mid. What is mid? Mid is 4 plus 7 divided by 2, that is low plus high divided by 2. What? Now mid become, this is become 11 by 2, which is 5. So again v of mid, what is value at index 5? Index 5 value is 60. Again 60 is less than target, that is our target value is 80. So again we will do same thing. Like, what will we do? V of mid is less than target, then we will do low equal to mid plus 1. Okay, third case, uh, in third step, low equal to mid and high will remain 7. That is low become 6 and high is 7. Again we will find mid. What will be mid? Low plus high by 2. What is, low is 6 and high is 7. What will be mid? Mid equal to 6. Again we compare value at v of mid, comparison with target. And what is value of v of mid? V of mid is 70, sorry, because the value present at index 6 is 70. Okay, 70 is less than again target. What will we do? We will do low equal to mid plus 1. Same case as previous, like v of mid is less than target. What will we do? Low equal to mid plus 1, and high is equal to same case previously high. What is mid? Mid equal to 7 and high equal to 7. In this case, high equal to 7. Low mid equal to low plus high divided by 2, that is 7 plus 7 divided by 2, which is 7. Now we compare value at v of 7 with target. That what is value at target? V of 7 is 80. It means that these values are equal, so we simply return mid. It means that our answer is present at index 7. So we, like, you can see that answer 80 is present at index 7. Okay, this is one. So simply we get our answer. But there is one case that if the value is not present, and where we have to stop our, like, we are checking and where we stop. Like, what we are doing, that we are like low is 0 and high is n minus 1. Low is 0 and high is n. We can divide our array into two parts. Like we divide our array of size n into n by 2. Okay, and then again we divide it into n by 4. Like, n by 4 become, then again it become, like, we are dividing our, we find mid and we will take only one part and we will exclude another part. Like, if our, like, we are comparing our value, comparing with like mid. Like, if mid is equal to target, we return mid. If mid is greater than target, we make our range from low equal to high, we change high equal to mid minus 1. So our searching space always reduces by n by 2, which I mentioned here. Like, firstly it is like n, then n by 2, then n by 4, and so on, like n by 8 and so on. Like, it become, at last it only one element will remain in our array. But like, if the we are searching for 80 and the last element present is 100, so it means that our target is not present, and after that our low will pass high. Like, if the element is only one element is present, low equal to high. After that our low become greater than high. In that case, it means that there is no element in our search space. Like we are searching, like when low is here and high is here, it means that there is the element present between that range. So we can search for our answer. But when low crosses this, it means that we check for all the elements. Okay, so there is no element, so we stop. It means that we return -1, because they in question they ask that if the element is not present, return -1. So we return -1. So now let's analyze the time complexity of it. What will be time complexity of it? uh, so the so you can see that we divide for every time we divide a array by 2. Like firstly it become n, then become n by 2, then become n by 4, n by 8, and like then it become, at last it become 1. Okay, like n by n equal to 1. Okay, now let's write it as, like we can also write n as 1 upon n upon 1. Okay, which is 2, 2 power 0, and we write 2 as 2 power 1, and 4 as 2 power 2, 8 as 2 power 3, and then so on, is like 4 2 power 16, then it becomes 16, it becomes 16 next case, like so on. Like at last it become, like for kth, kth step, it like it, we assume that it is kth step. For that it become n upon 2 power k. Like we also write n here also, like this one. So what we do that, like from this we get that 1 equal to n by 2 power k. So we, where n equal to 2 power k, now we can simply apply log both sides to solve this expression. It become log n and log 2 power k. Now we know that log, for this log a power b equal to k, it become k log 2, k log 2. It become k log 2. Now to find value of k, we will write as log k equal to log n divided by log 2, and it, we can simply write k as log 2 power n. So we derive that in the worst case we have log base 2 and operation steps to when we divide. Like when we divide, we only divide by log n time, and you for a very huge number, a log base 2 power is very small. Like uh, log, by log 2 power n mean that how many time we divide we divide a number we divide a number we divide a number by 2, so that it become 1. Okay, now let's see the for now let's see what will be log value of like log value of 1 crore. Okay, log 2 power of 1 crore will be, like you can see that log, if we have given an array of 1 crore size, then we will search our element, any element. In worst case, the time it will take only 23.25 operation. That is with log of 1 crore equal to 24, we take it at 24. Like in worst case we will only do 24 operations, but if we use linear search instead of this, we have to do 1 crore operations. So you can see that 24 in when we compare 24 with 1 crore, 24 is negligible. Okay, so you can think that how optimized this binary search is. Now let's write pseudocode for this. Okay, we have given a function uh, in which we are given a vector, or we can take it as array, and we have given a target. Okay, target. Okay, now what will we do? Like we take two variables, like low equal to 0 and high equal to size -1, where size is size of this array. Okay, size of array. Now, like we have to this do this operation for k time. So for iteration we have to use a loop. So we use while loop in this case. But I already explained you that what will be the base condition for that. Base condition is that when our array size become we that it means that when there is no element in our array, so that it means that when low is less than equal to high, it means that only when there is element present in array are greater or equal to greater or less than equal to 1, greater or equal to 1, then we will do this these things inside while loop. Okay, by because in every when we find mid we decreases our search range by half. Okay, so like we have to find mid, int mid equal to low plus high divide by 2. Okay, now if what we now we write I already write these steps. Like what we have to do, we only have to we have three operation. Like we have to compare if the value is target compare equal to target, then we have to return mid. If v of mid is greater than target, then we have to return then we have to decrease our search range to the left half, because the element which we are searching is less than mid, so it always be present on left hand side. So we exclude our right array. Okay, right portion of the array. So what will we do if v of mid equal to target, then we have simply return our mid is our answer. Okay, now another case is that if v of mid is v of mid is greater than target, in that case what will we do? Like this one case, if v of mid is greater than target, then we do high equal to mid minus 1. V of mid is greater than target, then in that case high become mid minus 1. Or else case which is that is me of mid is less than target, it means that our target is greater than our mid element, it means that it is present on the right hand side of the array. So in that case we choose low equal to mid plus 1. And at last if we don't find our answer, then we will return minus 1. But that is a simple code of binary search. Simply we are given a vector and our target, and we simply take low as 0 and high equal to size minus 1, and then we simply do while loop while low is less than equal to high. That is when we do while loop until when there is a on one element or more element present in our search space, because we don't erase element from our array, we only mention that our search range start from low to high. Okay, then we find mid and then compare to target. If value is equal to target, then return mid. Otherwise there is two cases, v of mid is greater than target or less than target. If it is greater than target, then we return then we do choose our search space between low to mid minus 1. In that case we choose high equal to mid minus 1, and other case we choose low equal to mid plus 1. Now let's write C++ code for the same. But we have first if we declare a function and we return int value whether in which index this is present. We name function as binary search, and we take a vector and target value. And we will check if we choose low as 0 and we choose high as v dot size minus 1, because we it's already I already explained in the pseudocode why we choose we do minus 1, because the array indexing start from 0. Then we will do while loop. While low is less than or equal to high, then we will find mid equal to low plus high by 2, low plus high by 2, low plus high by 2. Now we compare if our mid value is equal to target, it means that we find our result. Then we will return mid in that case. Else if v of mid is greater than target, in that case, that it means that the element which we are searching is less than mid value. In that case, we shift our search space to left hand side, like because the element on the right hand side are greater. So in that case, our high become mid minus 1. And in another case, we simply do low equal to mid plus 1. And if our answer is not present, then we simply return minus 1. Now let's save this code. I already have input an, target and vector. Now simply call this function int index equal to binary search. Then we will pass v and target. Now let's print the index of this now you can see in left right hand side I have given 5, that is size of array is 5 and target is 100, like 100 is not present, like we give target at 30, and we will searching that if the element is present or not. Now run this program. Now it gives the index is 3, it means that the element is present at index 3. You can see that the value 30 is present at index 3. Now let's check for 300. Now it will give minus 1 because the 300 is not present. I hope you understand what is binary search. Thank you for watching this video.